disable those that don't attend the. I have to be careful that don't attend. It's okay. It's a class and they don't come. They don't come. So for Vy, it's a circular pipe and it's straightforward because now for a circular pipe, it is equal to shear stress is equal to VQ over IT, right? You cannot use thin wall anymore, right? A pipe is a pipe, okay? There's no like thin wall pipe. I mean, there is, but for this case, it's not, okay? So from here, what is his name? Can you go over how to determine where the neutral axis? First, the neutral axis is, I know the position, or I know the location, exact position, I don't know yet. Okay, because this one has an axial load. So to Jivan, this is just a sketch. Okay, I need the sketch to look at deformation. Okay, so what do I mean by deformation? That's where Poisson Lai asks, why is moment mx a moment and not a torque? Okay, so if I look at the deformation, all right, it will deform this way. So when the deformation is either a smiling face or sad face, right, it is due to bending. Okay, so that's why it's bending moment. If it is a torque, okay, if let's say we look at a torque, which we can't see from this view, okay, if to draw a torque, I have to look at another view. But let me finish over here first, okay? So this one, we are coming back to here. Lai, I'm not forgetting your question, okay? I'm just complete this view first, then I move on. Then I'll do your part, okay? Because they are coupled, okay? Let me tell you why I'm coupled. So then on another context, so this one, okay, where Vy is equal to 600. So that's the formula we're going to use, and it's going to be thick wall analysis. Okay, for this case. So we know that element H, the shear will be equal to 0, right? Whereas for element K, is going to be our shear max because it is at the centroid, okay? So over here, we also have a PZ. So PZ is equal to 2,500 Newton, okay? And this is basically, you're going to find that it's going to be, for element H, is going to be compression. And element K, okay, element K, I should be writing better. I'm so disgusted with myself today. Element H and element K, right? They are all under compression. Okay. Yes.
Professor.
Yes.
Why do you have the 600 newtons going down right above element H? I mean, I caught you saying that it's a reaction force, but what is it a reaction force to?
No, so it's not reaction. It's flowing the deformation, following the deformation.
Oh, okay. So it's just the force relative to the position of the.
I'm not doing reaction because we did not do summation about forces in the x, y, or z, or moment about x, y, or z equal to 0. You agree?
Okay, yeah. So that 600 is just like
Yeah,
it's the
the
same
force.
force as the one on the left. It's just
Yes.
positioned
So you have
relative
to,
to the elements.
you have to transfer it over because we are looking at how the element will deform and the deformation, how is it related to our stress state.
Thanks.
Like what I told you all before, element H and K in real life, what are they? They are strain gauges, yes?
Yeah.
Right? Yeah, so that's why I asked. That's why I find important that I tell you guys what it actually is. Okay. Then you can visualize real well. Not it's so abstract. Okay, so that is all the stress state I know. Okay. Now, Mustafa, is there any stress state that you see I'm missing or no?
No, there's only the two forces on it. So,
Right?
I mean, there's a torsion, but not on this view.
Yeah, not from this view, right? So because why I'm saying this is because I'm not prepared for this lecture at all. what you see me doing is live. Okay, I just got a question from the homework and just put it here. But I want you all to also think about how I'm viewing things. That's why I'm not looking at the solution at all. And I will make mistake. Okay, I hope I don't make too much of it. Like today. Today is disgusting, man. So the next view I'm going to do is I'm going to do, this is X and this is Y. So I'm going to view it this way. So what we see now is this. Right? And then there is a cross at this point. And the cross is going in by 2,500. Oh, they are all in pounds. Sorry. Aye, 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 aye. Okay. Then we have a load coming down here. Right. So this load is going to be 600. There's a load at the cross. That is our 2,500. Okay. Now, again, you have to draw your element. Only after you draw your element, then you know where is your what neutral axis. Because if you don't draw, you start doing this. This is my element. This is my element H. Right. This is my element H. Right. Then this is my element K. If you don't draw your axis of your neutral axis of interest that's relative to the element, which axis are you focusing on? Okay, so I'm going to copy and paste what not to do. Okay, so you don't draw any axis, you draw the axis with the element of interest relative to the element that you are interested. So you don't draw, so all of a sudden, oh, Eugene say draw neutral axis, so I will take this. Okay, I will take this and I'll draw this neutral axis. For example, okay, so this is what not to do. Okay, but we're not interested in that neutral axis because both the elements are not on that neutral axis. The neutral axis that is interested is this neutral axis that I'm going to draw in green, right? Because if you use this neutral axis down here, now during deformation, what do you see? You see your structure deform this way, right? You see your structure deform this way, which is wrong, right? If you consider the axis, yeah, your axis deformed that way, but that's not the axis of interest. And then you'll say, okay, if the Eugene say that it is set face or smiling face, this is a bending moment, right? This is a bending. Better not use acronym. This is a bending moment. Then your answers will be all wrong. Okay. If you look at this view, okay, the correct way. So the green part that I colored is your neutral axis. When 600 has been acted upon, how does the deformation look like? The deformation look like this. Okay, so the deformation will look like this. And what you realize is that what? The neutral axis did not move. Okay. However, twisting, right? It's rotating, right? Twisting occur. Okay, twisting occur. So when this is the case, you know that over here, so this is X, Y, Z. Okay, you know here that you have a torsion in the Z direction. Lai, are you clear, Lai? Wow, so many questions already. Lai, is it clear to you, or you are still like, okay, yeah, good, okay. So for this case, that's why tongue tied again. Talk about Z axis, okay, is 600 multiplied by 600, 2.5. So it's 600 multiplied by 2.5. It's equal to 1,500 Okay, pound inch. So we get that. Okay. Okay. So I will come back to this question. Okay, but I will go through what Mira and Roseanne is asking. You have the shear as due to the shear force and not to the torsion. But the 600-pound rotation causes rotation of the neutral axis. 600. No, it causes a bending moment. Viewing this from 2D, Mira. Okay. Well, yes, the torque. Okay, the torque is so the 600 causes two things: the shear force and also the torsion. Okay, Mira, is that okay for you? Or you still
Sorry, you cut out when you were answering. It causes both a shear force.
hello?
Hello, can you hear me?
Yeah, I think there's something with my internet. So it causes both the shear force and bending moment for the 600.
But it also causes a torque.
Yes, if you view it from
So-
another view, it also generate a torque.
Okay.
Okay,
Thank
it can do three things. So that's why it's important to look at the view. Yes or no? If I just look at this, okay, I can't tell. If I just ask you, okay, how many components or how many forces, I can't tell. Am I right? Mustafa, can you look at the answer for me? Am I short of anything, or I'm over adding a load? Can you tell me, Mustafa?
No, it says P is 2500 compression, Vy -600, Vx 0, Mx 1500, My 0, and then Mz, it's a moment, but it's a torque 1500.
So we are correct, right?
Yeah, we're correct so far. You've caught all the applied loads.
Yeah, and it's easier by doing it in 2D. Am I right?
Yeah, well, you don't miss anything once you hit
Yeah.
every station. You don't miss anything.
Exactly. So now I just look at the I did not use the same technique, is it? Right? If you're going to use this method which show in the solution, I'll tell you this. You're going to make mistake. I repeat again. You're going to make mistake because I tried, did not work at all. And I tried and did not work at all because I realized what? Our paper that we write on is what? 2D space. The real world is what? 3D. So when you use this technique that I've developed, okay, you will not get it wrong. Are we clear? Okay. If not, if you look at textbook or the solution manual, if you look at the solution, you don't follow my technique, then you'll be scratching your head. What am I looking at? You get what I mean? Okay. You don't know how they get the 1500, 600, or 2500 is straightforward. Okay. Any questions so far? Are you good? Okay, so let me finish Mustafa's question regarding the torsion. Wait, Mira, are you okay now?
Yeah, I was just confused because I thought that it could only cause one type of shear stress. It
No.
could cause both. So okay. That makes
Yeah.
sense though. Thank you.
Yeah, but I tell you, I did not know until I draw those three views or two views. I did not know until I constructed this view. Come on, work. I constructed this view and this view. I did not know by looking at 3D. I'll tell you that. Okay. So, i.e., what's the difference between you and me? We have the same level of intelligence, only I have more practice. That's it. Okay. I'm nothing special. Okay. I want to train you guys the same way to achieve this skill when you guys are younger. I'm nearly 50. You guys are 20 or below. I want you guys to excel. Okay. Now, Mira is okay. Roseanne, you are saying along with the question above, do we only focus on each orientation at a time, so the same force causes a bending in one view? Well, Roseanne, you're absolutely right. Okay, I want you to watch the chat. Okay, I think Roseanne, you got it there. Okay, I totally agree. So the same force can cause different things. Okay, but sometimes the same force in one view and another view are the same. Okay. Okay, so Roseanne is done, and Hussein is okay, and Mira is good. Okay, so now we know that we have we have okay, let me see, can I squeeze here? Okay, so we have let's look at our shear. So our shear Vy is 600. So let me, Vy is 600, torque is 1500. Shear Vx, yeah,